Today we'll be talking about the shape of data. Essentially, we're going to be talking about the different kinds of graphs and what they'll be used for, just to give you guys a bit more information. You will be making graphs during this week's class, so you can use either Google Sheets, or you can do it on paper. It's completely up to you. All right, so the four types of graphs that we're going to focus on are a circle graph, a line graph, a scatter graph, and a bar graph. So a circle graph displays data that represents parts of a whole. So that's why we talked about percentages. And a line graph displays data that change over time. On a line graph, line segments join data points together. Then we have the bar graph, which displays data that can be counted. So two sets of data can be displayed on a bar graph. You can even have 3, 4, depending on what you're trying to show. Could end up being a very large bar graph, but you can compare a bunch of different data sets on a bar graph. A scatter plot displays two related sets of data that are measured or counted. So that means that you have numbers along here and numbers along here. So, example, this table displays the life expectancy at birth for people born between 1920 and 1990. Okay, so you'll see as people get old, that as the birth years get higher, you'll see that the life expectancy goes up. And there's a lot of reasons for that: medicine, science, all those things that have advanced over the years. So we have 3 questions we're going to look at here. A person born in 1970, how long can he or she expect to live? So to find that, we're going to find 1970 on the birth year side, and the 2 numbers next to it are 76 for females and 69 for males. So we know that there would be an average there of 72.5. And we know that, is that right? No. Yes, 73.5. I'm trying to do math in my head and it's not working today. But we know that if it was female, they would have a life expectancy of 76. If they were male, 69. B, which type of graphs could be used to display the data? So we have a few different things here we could do. We could do a bar graph so that we can compare the 2 sets of data. That's an option. We could do 2 different line graphs, one for female, one for males, to see the change over time. That's also possible. Or we could do a line graph with 2 lines so that we can see the change over time for both males and females. C, how could the graph be used to predict the life expectancy of females born in 2010? What assumptions are made? So if we're going to go over here to the solutions, we already talked about this. But let's look to C. Okay, to predict the life expectancy of a female born in 2010, extend the last line segment. So see how this is a straight line from one dot to the next. You're going to extend that until the point where 2010 would be. So we skip 2000 and we go right to 2010. And that is where we want to know where the line ends up. So from the graph, the life expectancy of a female born in 2010 will be about 85 years. We assume that life expectancy will continue to increase at the same rate as it did from 1980 to 1990, but this may not happen. So this is what we were talking about yesterday, inferences. We can make an inference that it would go up, but it's not guaranteed that just because the data shows us we're going to go that way doesn't mean that we're going to actually necessarily end up there. So you're going to practice choosing graph types. You're going to practice maybe making a few graphs, and it's going to be page 203, number 1 to 5. All right. If you have any questions, make sure you hop on to the Google Meet at 1.